Hey guys, so this is just a review of the structure of the atom, and you might remember from class that the atom has three subatomic particles. And these are really, really important to remember the difference between them, where they're located, what their mass is, and what their charge is. So the proton is pretty easy to remember because it's positive, so P for positive. It's in the nucleus, and it does have mass. Its mass is about 1 AMU. The neutron is also easy to remember because N, neutron, neutral. So it even sounds like the word neutral. It's also in the nucleus, and it's about the same mass as the proton. So they're both quite large in relation to the electron. And remember that the electron is zipping around the outside in those defined clouds, those defined cloud regions. And the electron is negatively charged. It's outside the nucleus, and compared to the neutron and the proton, we say that it has no mass. Now, this is going to be a really handy-dandy little graphic organizer for you. Our brains tend to like to structure information, especially when we have to remember the difference between them. So I would highly encourage you guys to copy this or take a screenshot of this and put this in your OneNote notebook, because this is really going to help us to remember the difference. And because we have these different symbols here, so instead of writing out the word electron every time, when we write this E with a negative, we all know that that means the electron. Again, it has no mass, it's negatively charged, it's outside the nucleus, and its function is to control the charge. The proton is what defines the element, and the neutron actually changes the mass of our atoms. Now, atoms of any given element will always have the same number of protons. So the number of carbon atoms, like the number of protons inside carbon, is always going to be 6. And that's going to be different than the number of protons inside oxygen, which is 8. This is what we call the atomic number. So the atomic number equals the number of protons in an atom of that element. And I have this little picture of a fingerprint here because the number of protons is the atomic number, which is kind of like a fingerprint. It's extremely unique and it's different than any other atom on the periodic table. So if carbon always has 6 protons, then it will always have 6 protons. If it has 6 protons, it's carbon. Oxygen's fingerprint would be 8 protons. So if oxygen will always have 8 protons. If it has 8 protons, it will be oxygen. So you can use atomic numbers to refer to elements like names and symbols, because we know that if it has 6 protons, it will be carbon. Atoms of different elements are going to have different numbers of protons, and that's how you can kind of tell the difference between the two. Now, the other thing that we know about atoms is that most atoms from the periodic table are neutral. So what that means is that the number of protons equals the number of electrons. So if oxygen has 8 protons and it's neutral, then it will also have 8 electrons. The last piece of information that we need to know is the mass number. So the mass number is the sum of the protons and the neutrons, because remember, all that mass is contained inside our nucleus. And to find this, we just look at the periodic table, we look at the number that's there, and we just round it to the nearest whole number. Remember that both protons and neutrons are both 1 AMU, so the mass number has to be a whole number. So if we are trying to find the number of neutrons, then we can just work our way backwards. We can take the mass number minus the atomic number. And remember that every atom on the periodic table does not always have the same number of neutrons. The number of neutrons can change, but that won't change what element you have.